Okay, so let us discuss the method of undetermined coefficients. If this is sine, you will write imaginary. If this is cos, you will write real part. Depends upon sign difference. So the method of undetermined coefficients, in short what we call UC. So again the idea would be same. We find complementary function with the help of same method.
So undetermined means you are talking about infinite.
No, undetermined means I don't know their value, but I have to determine their value with the help of substitution or some other ways. So basically this method helps us to find out the particular integral. Complementary function, we know very well already. You solve the auxiliary equation, quadratic, cubic or whatsoever. So I am making a table in which I am first writing the form of the right hand side and then
Solutions of
what we call assume yp is given in this one. So the idea of this method is you will assume your yp and you will find the undetermined coefficients in your yp, substitute in that one, that's your answer. This is the idea behind that. So what should be the form of your f of x? The first form is it's going to be a constant. So what should be the form of yp?
y equal to a
C.
Again it's going to be
Okay.
any constant, but you have to find out the value of constant. There are some restrictions in method in this one which I am going to tell later on. Okay, what if you have some ax raised to n where n is a natural number? It means any polynomial of nth order. So what should be the form? It should be a naught x power n, a1 x power n minus 1 up to
a naught.
Now third one is if this is exponential
Power x.
e power
A
x, then it's going to be some constant
e power
e
x.
power x. Okay. Fourth,
Sin
what
x.
if this exponential is multiplied with
X power x.
it should be some coefficient here as well. Let us name it c1. And this is some c1 x power n. When these are multiplied, then you have to write e power x and then you have to multiply with the nth degree polynomial, that is a naught x power n plus a1 x power n minus 1 up to an. Nth degree is given to you in f of x. Assumption of yp should be this whole. It should not be only a single thing. It should be this whole. What if your function contains sin x or cos x? Sin x or cos x? Then it should always be a sin x plus b cos bx. B cos ax. You will always include both. Whenever your right hand side is whether sine or cos, you will always include both of these things, not only single thing. Why? Because the derivative of sine is cos and the derivative of cos and sine. In differential equations we involve derivatives, so we have to include both. Okay, then you have like sine and cos multiplied by exponential, sine and cos multiplied by x, the idea would be same. So I am not going to write those things. This is the idea that we have to assume by ourselves. So we are doing some examples, the idea would be totally clear. We have to assume yp to be either this one or this one or this one or this one. We have to find out the value of these coefficients by substituting into our original equation, and we have to substitute the values here, that would be our yp. What is the changing in this one? What is the problem here basically? We have to multiply everything with some x raised to k, and then we have to decide what should be the value of k. This is the problem in these methods. So when we are doing an example, I'll be telling you what happens exactly and how to decide the value of k. So x raised to k and everything multiplied by x raised to k. And we have to decide that the value of k should be either 0. If the value of k is 0, then no need to write this. The value of k can be 1, can be 2, and so on. Find yp in this case. d2 minus four d plus 4 e raised to so in this case we have to find out yp. Can you tell me what is yc?
yc must be a e power minus 2x.
yc.
yc.
No, I'm not talking yp. yc means solve the homogeneous part.
Yes,
It means solve this equation m square minus
plus minus 2
Plus minus 2 minus 2 is 0.
Is this okay?
minus 2 plus 2.
So both are equal.
m equal to 2.
Your yc is
C1
c1
e power
c1 e power 2x
plus C1
x.
x e raised to
X
2x.
power 2. Yes, sir.
Okay. Now you can see the right hand side does not appear in your yc. E raised to minus 2x is not this one, is not this one. So what should be your yp? Your yp should be e raised to minus 2x.
Plus yc.
Where is this one? Multiplied by some constant a and multiplied by x raised to k.
So what is x power
K should be 0.
Why?
Because this particular thing does not appear in your yc. It is not same as these. So we are simply neglecting this term.
If it is,
If it is, then what happens?
yes,
Now I am considering this to be this.
fine.
Now my right hand side is e raised to 2x.
Twice time k.
Now this particular thing appears in your yc. So you cannot write the same as this. You have to multiply with x. But again this appears in this one.
Right.
Then you have to multiply
Fine.
x square, so the value of k should be 2.
You got to.
Otherwise you won't be able to solve or to find out what we call linearly independent solution. You have to check this thing always.
एक देखो
कितने?
only x
हाँ.
इकडे मुझे
कितने मुझे? कितने मुझे? Anyone?
It means we have to check on number of times. E power x.
We have to check only yc,
Right.
and yc contains either 2 or 3 or 4. You have to check each and every term.
If it exists in
Yes.
in the series
But
of
okay, if this is e raised to 3x, then there is no problem. Because this is not e raised to 3x, this is not e raised to 3x. But if this is e raised to 2x, then this appears here. I have to write something which should be different from these two. And the different thing is you have to multiply with x. You have to multiply x once and twice and thrice when you get something different and something new. Now you will solve it. This is your yp. It means this is simply your y. What you need to do, you need to find out the value of a. How to do it? You will substitute this particular thing into your
Equation.
differential equation. So it means you have to differentiate once, and the derivative of this one will be product rule. And what should be the product rule?
ax square
Ax square e raised to 2x multiplied by 2
plus
2a e raised to
2x
e raised to 2x. Derivative of this one, derivative of x square is 2x. Okay?
Yes.
Then y double prime,
and
I should write this in some other form.
2a common
2a x square
2e
plus
power
2ax e raised to 2x. Now it's okay. Y double prime would be, the derivative of this one would be 2 e raised to 2x, this thing remains same, 2ax square plus 2ax plus derivative of this thing, and e raised to 2x remains same,
so 4x
4ax
plus 2a
plus 2a. So this is y double prime. We have to put in the differential equation and determine the value of a, and then let's see what happens. So this d square y means
2 times
Second derivative.
2 times derivative. It means this is the value. I am just going to put this one by taking e raised to 2x common. This is going to be 4ax square, 4ax square plus 4ax and then 4ax. So I am going to write simply 8ax plus 2a, and then minus 4 times dy means the derivative. What is that? This one. So 2ax square plus 2ax e raised to 2x. Okay. Plus 4 times y. Y is a x square e raised to 2x equals e raised to 2x. Now you have to just solve this to get the value of a. And the idea is you can cancel e raised to 2x from every term.
Yes.
It's possible
Yes.
by taking something common. So 4ax square
Minus 8
minus
8
8ax square
plus 4
plus 4ax square. So you may simply
Yes, sir.
cancel out the second power of x. 8ax
Minus
minus 8a
minus 4 times
2 times. Yes, sir. 2 is equal to 1 now.
then what happens?
2a is equal to 1.
2a
Is equal to 1.
is equal to
1 upon 2.
a equals 1 upon 2.
Yes, sir.
So yp is going to be 1 upon 2x square
E power 2x.
e power 2x. I don't believe that this is going to be right. So we should check it. We should check it whether it's going to be right or not. And we know very well from the previous method we have 1 over f of d e raised to x. Okay. You know very well f of 2 is going to be 0 because this particular thing appears in yc. Okay, and f prime of 2 will also be 0
Twice
because
time.
this thing also appears. So you have to find double derivative and then put your answer. So we can check this thing. What is Rf of d? Rf of d is d square minus 4d plus 4. If I put 2 here, that's going to be 0. Let us find the prime. That's 2d minus 4. If I put 2 again, that's going to be 0 because of this term. So I am going to differentiate. Again, that's going to be 2.
2 only.
I am going to put 2 now. 2, no problem.
Only a 2.
So the answer would be f double prime of a.
X square.
Compensation is x square e raised to 2x. F double prime of a is
2.
2. So this is x square e raised to 2x
Upon 2.
upon 2. Just same as this one.
Okay.
Now you can see the difference, the time and the difference. So that's why I usually don't prefer this method.
सब पढ़ रही
Undetermined
वो
coefficient.
इसके लिए अच्छा कार्य नहीं किया होगा
No, the problem is, only one problem is, you have to decide what should be this one. And if in exams only you are asked find yp, then you must need yc to decide that what should be the value of k. Because you found yc and you saw that okay, this yc contains this term, then I should make this thing different. That's why I should put x square. It means we should solve for yc as well. Otherwise we will not be able to find. This is yp in 2 or 3 steps. Sometimes this is tedious, but most of the times it's going to be very easy. So if you can say, I can solve some other examples on this one as well. But I think we should go ahead. Okay, there are some special equations with variable coefficients that we can solve, but we cannot solve all the linear equations of higher order with variable coefficients. One of the special type is what we call the Cauchy Euler equation. So the Cauchy Euler equation. We can solve this easily, and it's the only equation that we can solve having variable coefficients. Let me write the only second order version of this one. That is simply, if you have second derivative, then it is multiplied with the second power of x. And let's assume the coefficient is a, plus y prime, it is multiplied with x power 1
Only 1 plus
plus c y.
I.
This is no derivative of y, it means it is multiplied with x power 0. So I can simply ignore it. Equals sum f of x. You can see the problem with this differential equation is the variable coefficients.
Variable coefficients.
So we cannot solve with the ways that we have so far.
Yes, sir.
So either we have to assume some sort of other solution, or we have to make this free from variables,
Variable, yes, sir.
the variable coefficients. So the first thing is that again we will solve the corresponding homogeneous equation. So corresponding homogeneous equation would be ax square y double prime plus bx y prime plus cy equals 0. There are two ways to solve it. Method 1 is assume that this is its solution. Y is equal to, now it is not exponential form, it is some power of x.
Yes, sir.
X power, and we'll assume that this is the solution of this Cauchy Euler equation in the form of a we can say it polynomial, but it's not always, because the value of m
Yes,
can
sir.
be anything.
Can be anything.
It's not always integer or natural number.
Natural.
So this is our assumption. The second method is we have to convert this into constant coefficients. These are two methods to solve it, and we can apply both of these methods, not a big deal. So let us see how we can apply this method. What's going to be y prime?
mx power
mx power m minus 1. What's y double prime? M
M square minus
m minus 1,
Yes, sir.
not m square. M minus 1
Yes, sir. Multiple.
power down, and substitute in this one ax square. What is y double prime?
M into
m
M
square
This
minus m
m minus 1 and x power m minus 2
2
plus bx y prime is m x power
M minus 1.
m minus 1 plus y is x power m equals 0.
C x power M.
Now when you multiply these two terms, what happens?
x power m
X power M.
X square and x power m minus 2.
Yes, sir.
X power m.
Yes, sir.
And what about this one?
x power m
And what about this one?
x power m
You take x power m common,
Comma.
and this is
am square
a m minus 1
Yes, sir.
plus bm plus c. Again this is not 0,
Not 0.
not possible.
not possible because this is exponential. This is going to be 0, which is your auxiliary equation corresponding to this, what we call Cauchy equation. Again, you will assume there are different cases in the roots, and your solution would be x power that, x power m1, x power m2, or whatever.
Yes, sir.
So let's see what happens. So I'm not going to solve any example, but I'm going to give you the bigger picture that you can solve it in this way.
Sir, m belongs to what? An integer or something?
M can be integer, can be a real number, can be natural number, or whatsoever. But it would be an algebraic number. It would not be a transcendental number. And you should know what's the difference between these two. Square root 2 is algebraic. Pi is not algebraic, it's a transcendental.
Yes, sir.
E is not algebraic number, it's a transcendental number. So algebraic numbers are those which are solutions of some polynomial equations with what we call rational coefficients. Polynomial equations with rational coefficients, the solution is always algebraic number like square root of 2, square root of 3, 2, 3, and so on. Solution will never be E, the solution will never be pi.
Yes, sir.
I'm talking about polynomial equations, not trigonometric. So you solve this. Case 1 is roots are
Real
And distinct.
real and
distinct
distinct. So the idea is very simple in this case. Your solution would yc would be x power m1, x power m2, and because our assumed solution was this one,
Yes.
you will put the value of m1 and m2, and you will simply take the linear combination.
Yes, sir.
That's the solution. That's the solution. The second case is
Real and equal.
roots are
real
And equal.
real and
real and equal
real and equal. So what should be yc in this case? Again,
C1.
I'm saying m1 is equal to m2 is equal to
M.
m
m. So c1 x raised to m, c2 x raised to
M.
m. So you can see both are same. So what should be the compensation?
log x
Log x. I think this is not in this book. Is it? Are you okay with log x?
E power x. Then
You two all of the same.
Case 3, roots are
conjugate complex
complex conjugate, or just write imaginary for now. And we are assuming our m1 is alpha plus iota beta, and m2 is alpha minus iota beta. Then yc is going to be c1. Again, I think e raised to alpha x will remain same in exponential, or no, it's
x
not
power
exponential.
alpha
It's x power alpha
जी
because it's not the ordinary one.
x power alpha
X power alpha,
c1 cos beta log x
yes, x power alpha, and c1 cos
beta log x
beta log x plus c2 sine
beta log
beta log x, and beta log x is going to be the angle. Beta log x is going to be the angle. So these are different ways. The first method to solve Cauchy Euler equation of second order, and these are different three cases for the roots.
Variation of parameter.
What is the alternate method to solve it?
कलाम बन गया मदद उठ रही है
So method number 2, it's conversion into equation with constant coefficients. Now the next idea is we want to convert that equation into constant coefficients. And how to do it? The substitution for that one is, since in our equation the independent variable is x,
गार्डन में लड़ो चाहे
so I'll put x is equal to
डिटेल डजंट ग्रीन में ये गार्डन
Power
में
t.
e raised to t. This should be the substitution. Or t is equal to log x. So this substitution leads us to an equation in y with independent variable t, but it would be having constant coefficients. Then at the end we'll solve that equation in t, but then we have to convert t into x, and then at every t we'll put log x. And because of that, we can see this is log x, this is log x, this is log x, because of that. Otherwise there is no any idea behind that. We'll take this substitution, we'll substitute into our equation, that would be equation with constant coefficients. But you have to convert everything. You have to convert dy by dx into dy by dt, and you have to convert d2y by dx2 into d2y by, you have to do these conversions. How will you do this one?
dy by dx.
Can you write dy by dt
dt dx.
dt by
10
dx? So this is dy by dt. What is dt by dx?
1 upon x.
1 upon.
X.
So your dy by dx is going to be
This
dy by dt into 1 over x. When you multiply x on both sides, x dy by dx becomes
dy by dt.
dy by dt.
Again
And
differentiate.
this is x dy, because you know very well dy by dx can be written as dy. In the form of operators, just ignore y. And this dy by dt, you can name it, let's say delta. You can name it delta. So what happens in your Cauchy Euler equation, every derivative has power of x. Now that power of x is only converted into dy by dt. Power of x has been removed. Similarly, you will find out this thing, you will substitute back into your equation, and there will be no any powers of x. It will be in t only. So you can do that one, I am not going for that.